Hello, friends, and welcome to another episode of the AI Show. This is Seth here, coming to you from deep inside the bunker that is known as my house. Here's a quick question. My wife's been telling me, and she left, so she went outside. She said that I need to redo the background. I don't know. What do y'all think? Is it too unprofessional? She said that, and then I laughed. I was like, do you even know me? Pretty excited today. We're going to keep working on our Rochambeau project, which is a new word that we all learned. Also, I was in an email thread a while ago about technology we're going to talk about today. And I was like, I don't know if it does stuff for me. And they're like, oh, no, Seth. No, it does. And so we're going to have a special guest on today to show me how to actually use it right. I've been holding it wrong the whole time. So we got that going on. And I figured today, let me go ahead and get my pandemic purchase equipment out. And let's take a look. Let's write down. Let's do the whiteboard stuff that we always do here. Whiteboard, even though it's like blackboard stuff. Number one, today, we're still working on rock, paper, scissors, but you know what? We're going to try a new way, try a better way to run this. I recently, literally this week, was shown by some fabulous people how to make things better, and they're gonna come on and show me how to do that today. Number two, we had some logging issues. I didn't get a chance to look at it, so we're going to figure it out together. We're going to read some docs, and y'all are going to tell me if they're good or not. And then number three, and this is, maybe we might interchange these. I don't know what. I was looking at the docs for, and it's not docs, right? Because it's basically, how shall I say this? Node. I'm not a big Node guy. But for some reason, our back end, we chose Node. And so we're going to try a little bit to get inference to work. And if it doesn't work, maybe we'll switch the back end to Python for Azure Functions. And so we'll figure out if that's going on. And so I'll let everybody choose which ones we do first. For sure, we're going to do number one. Because, I just learned literally last night, late at night, how to do some pretty cool stuff, and I want to show you how it works. Well, they're going to show me how it works in this project. All right, before we get to all the other good stuff, where is everybody coming from? Ivana is here. Bienvenida. Wow, this is a cool name. Igusti ungura putu oko oka mustika siswa. Did I just swear in a foreign language? We might have to bleep all of that out. Oh, no, maybe. Welcome. Ivana, welcome. Jay McCormick is here. Holiday weekend in North America. That is right. We don't have to work on Monday. I don't know. I have a good time. This doesn't even count as work. Microsoft developers here, so everyone put on your game faces. Game faces, everybody. Sharafuddin, hi. Who drew the arts on your wall? I did. You don't think I have? This is me. Does it look like me? My kids did. And at the beginning of the panna cotta, as we call it, they kept bringing in pictures because they'd see, when they go on the YouTube, I have these things subscribed, right? And they were like, hey, let's put more pictures on your wall. And so they brought more pictures. Welcome, everybody. Let's get some background music on here. Show us cool stuff. Yes. Hola, Senor Juarez Diaz Mera. Welcome. I'm so glad everyone's here. So that's what we're going to do today. Here's our project. But before we go there, I think, look, I'll be honest with y'all. One of the biggest problems I've been having recently is, and I've kind of just been eliding it, managing environments stinks for these kinds of projects. Oh, I need to turn that off. I was just the emphasis there for a second. It's like every time like I get something to work on my machine, it's like I try to make it work in the cloud and it doesn't work. And then if anyone's ever done stuff with containers, it's like if you make a mistake, you've got like 9 minutes of downloading a new thing and running a new thing, and then like 10 minutes of uploading a new thing. And I just want to know that it's going to work. Like my inner child screams to me and says, please, please, all I want to do is make this work. But it doesn't, you know? Yeah, Jenny Skew, number 7. By the way, 7 is a wonderful number. Of all the numbers to choose, well done. Bringing up on Twitch. It's like he's like, "Hello, I'm in Twitch. Is it anybody else here?" Thank you for that. So we're gonna try a new way of doing. I don't even know what this is. What is this? I don't know what this is. Audio conversion tool. I'm gonna close that. I don't know what that is. Like a random file. Everybody stole my hash now. Everyone has all my bank account. Well, joke's on you. I got 4 kids, so I got no money. Like every time at Microsoft, you get a bonus. Like dudes get like new cars. I have to pay for band. Oh, you need a clarinet. I hope it works for you. One time my daughter was like bent on having an oboe, and so I bought it. It was like $600. I was like, this is for her future, I kept telling myself. Now I need to learn to play the oboe to make up for that. So, all right. Let me bring on a guest here who's going to tell me that I've been doing things wrong. No, he's not. He's very nice. He's very nice. Craig, how you doing, buddy?
Hello. How's it going? I'm doing well. How are you?
Good. So we were on an email thread a while ago, and I was like, this stuff doesn't work for AI. And you're like, wait, no, Seth. When's the last time you looked at it? And then I was like, 18 months ago, which then you informed me that in computer dog years, that's like a decade ago, right?
Yeah, exactly. And we're talking about the Windows subsystem for Linux. So I am a program manager working on the Windows subsystem for Linux at Microsoft. And yeah, it has changed a lot. We've done some really cool stuff behind the scenes, and I'm really excited to show you the kind of the new workflows that we've unlocked in the latest updates.
Okay, so first of all, if you could give us a little splainer on what WSL is. I did a video on it many moons ago. It's absolutely amazing. Why don't you give us like the 10-minute spiel? Let me put your face on the whole way so everyone can see you. 10-second spiel.
So 10 seconds. The Windows Subsystem for Linux, or WSL, allows you to run Linux command line tools, utilities, applications, and workflows all directly on your Windows machine. So you don't have to have a traditional VM setup where everything's totally separate. You can access your files across Windows, across Linux. You have full interrupt. You can even run PowerShell.exe straight from a Bash shell, which is mind-blowing. And it's just a way to have it fully integrated environment. So if I'm a Linux user, I can access all my PowerPoint, Office tools, and Photoshop as like a front-end dev, perhaps. And if I'm a Windows user, I get the whole wide world of Linux to play with.
I believe in audio terms, it's this.
Yes, exactly.
Like if WSL had its own like walkout music, it'd be.
We should do that on every startup. You start up the terminal.
Yeah, well, every time WSL starts up. Okay, so the reason why this is cool for me is because particularly in AI, the workloads tend to be mostly Linux. Like there's certain things that like the Cocoa tools. If you don't know what Cocoa is, the Cocoa data set is the one for object detection. Like that library doesn't even work. Did I say library? I'm so sorry. Like
How
this
dare you?
is how. Like I didn't know that I was going to embarrass myself in front of the PM
I'm
from
embarrassed for
WSL.
you.
Yeah, library. The library is built by Microsoft, and it doesn't really work on Linux. I'm sorry, on Windows. And I've always wanted to do this, but like I started using WSL like many moons ago. I'm not trying to grab him there. That looks weird. Many moons ago. What's better about it now that I've totally missed the boat on, and you're going to show us?
So if you've seen WSL way before, we actually had a translation layer, and it was a really cool implementation where everything ran on the Windows NT kernel at the end of the day. We've improved that by switching to a virtualization-based approach, and we actually use a real Linux kernel built by Microsoft and shipped via Microsoft Update. So if you hit like Update and check for updates on Windows settings, you get a Linux kernel, which is awesome. And one of the cool things that we do with this is because we have virtualization, because we have real Linux running in the background, we can do like Docker containers. In Windows 11, we have access for GUI app support. We also have access to your GPU for AI and machine learning workflows.
We have to hold on. I gotta. That was the thing that I struggle with, because when it comes to containerization on Windows, I could never access the GPU, which is super struggle bus for me when I was trying to do AI workloads. Could you talk about that a little bit more, and then get to the rest, because I want to make sure we do a little stop on that one.
Yeah. So basically, what we did is it's actually a really cool change. We made a kernel change in the Linux kernel to add a device under /dev, and it's called the DXG device. And it is a device that basically forwards any GPU communications to your Windows GPU. So if you're used to using like a virtual machine, sometimes you have to directly assign a GPU to that. This is even cooler because you don't assign your GPU. It just works when you have the right drivers installed, which are like on Windows 11. They're automatic. And it also shares your main GPU on your machine. So I only have one GPU on my computer. I can use it both in Windows, like while I'm using Windows, and then be training on it simultaneously.
What? He's all like, I only have one GPU. We all do. I mean, I feel like the ones that have more than one are. One day I'll have more than one. I'll live in a smaller house though, but that's how it works. That's really cool. So one of the other things that's interesting, and this is the part that really like super got me excited, is that there is a way to actually develop on containers that now have GPU access to the GPU access through the Linux kernel. I need to draw a diagram.
Yeah. So basically, yes. What you can do is you can take your WSL instance, run a container in it with access to the GPU on Windows on your machine, and then you can develop directly inside of that container using VS Code Remote. It's a really cool workflow.
Whoa! And see, that is the part that I was like, because imagine a scenario, because the reality is whenever I do machine learning workloads, I'm testing stuff locally in order to make them run in the cloud. But anytime I make a mistake in the container, I'm talking like 20 minutes before I even know that I forgot another pip install.
Yep.
If it's local, a lot of these huge images are cached, and now your dev cycle is a lot faster. And so if you're running a container environment, if it works there, that container will work in the cloud as well, right?
Exactly, instantaneously. And you even get F5 debugging and all kinds of tools. So it's really, really neat.
So I thought you would help me with this. So what is it that I need to do to make it work? I installed a couple of things that you told me to. This thing, and then I think I had this thing installed. So, and I say this thing. Let me make sure everyone can see. This thing, and then this thing. Can you tell us what this one is, and then what this is?
Yeah, so this is VS Code, and on the right is the first one at the top is the remote extension. I was pointing to it on my screen, and I was like, no one can see that. What it allows you to do is when you click it, you can access remote instances and debug directly inside of them. So you can access things like your WSL distros directly. You can SSH to remote machines, and you can even access containers directly inside of it.
Oh, okay. And then this thing over here is just the standard Docker container thingy.
Yep. Just to look and manage what containers you got running.
So I'm going to open this one first. I have Azure registries. These are the containers that are in Azure ML that it manages. And then these are the containers that I have, like, for example, Torch Vision for a CPU. And this is just what this does. Now, over here, this is the question now that I want to see if I can figure it out. I ran something yesterday. I didn't know what was going on, and I thought we would start from scratch to get our Rochambeau project. And let me show it to you here. It's basically this trainer. If I say Python, let's see, Python trainer minus config. This basically, oh geez, conda activate torch. How embarrassing! in front of the PM from WSL.
I like your prompt, by the way.
Oh, thank you. Yes,
Power
this is.
line.
Yeah, I know. Isn't it beautiful?
Very
This tells
gorgeous.
me what environment I'm in. This tells me where I'm at, etc. Do you know a guy by the name of Ben Hillis? I think he works on your team.
Yes, I know Ben.
I was his TA in college. Did you know that?
Yeah, he told me that. That's so funny.
It's weird. Like, I was doing an interview with the WSL dudes originally, and he's like, "Hey, Seth," and I'm like, "Hey, how's it going?" And I'm really excited. He's like, "I was in your class," and I was like, "What?" Oh, Ben. Oh,
That's
no.
funny.
This is broken because I broke something. But let's break it inside of a container. How about that?
I'm all for it.
So let me go. Let me see. Maybe I can find the line where it's broken. Dang it. Because what happened is we broke it last time and I didn't do anything about it.
In fit.
Oh my gosh. Line 986. Oh jeez. Oh jeez. Oh, I know what it is. Something is not the right size here, I think. Let me see. But let's do this. Let's get the container to break. Let's get it to break in the container, because if we get to here, that means that it's running. And then I'll figure it out later. I don't want to waste time. All right, so I want to make a container. So obviously I need to have a container definition. What do I do? What do I push?
I would hit Shift Control P.
Shift Control P.
You're going to bring up the command palette and then just type in, there it is. Remote containers add development container configuration files right at the top.
See, I did it like last night, but again, I was tired. So I don't know if I did it right. So Control Shift P. I hit this. The workspace could fail to open container. So should I not do workspace? Should I just go to the actual project?
I think so. Yeah, I think that'd be easier.
Right. Let me try that. That way I can work on stuff separately. All right. CD Rochambeau AI echo dot.
Yeah, because it's going to make a .dev container definition.
Okay.
So what we're actually doing is basically making one folder, and it's helping you set up the files in it. So if you hit Shift Control P, bring that up again. Yep.
Okay.
And then there's a bunch of different definitions here. We can just choose any. I would just choose Ubuntu for now, and then we can go in and change it.
What if I have my own Docker? What if I can make my own Docker container? Like if I can do a Docker file, would that work?
Yep. So it's just going to give you like a default Docker file, and then we can put in whatever we want after that.
Okay, so should I just choose Focal?
Actually, wait, let's go back and see if they have choose your own. Perhaps they have that as one. I've always just used the sample. Show all definitions, perhaps?
Show all definitions?
Because I know they do some magic.
Bazel DBN. Oh, Docker from Docker? Oh, no. Docker in Docker?
Yeah, I would just choose Ubuntu, and then we can play with it. With what they have.
Oh, there's so many.
Yeah, there's a ton.
Oh man, there's so many. This is cool. So I'm going to do Ubuntu, and then we're just going to change it to whatever we want. Focal.
Yeah, that works.
Okay.
So it's created two files inside of a folder. Created .dev container, and then this is what VS Code looks at. So it looks at this dev container.json. And basically it's saying, what's the name of your instance, right? At the top is Ubuntu. What does it build from? Docker file. And we pass in some arguments to that. So like this focal argument. And then we can pass in settings, extensions, and all kinds of different things like post create commands. So this is where all the VS Code hook-ins, or I guess plugins come in. And then if you click on that Docker file, here's the Docker file that it's building from. So that's all.
See. Well, why don't I feel like, because if I'm understanding this right, this here is going to add a bunch of extensions in the container for VS Code for me to work with, right? So basically running VS Code inside of the container. Is that right?
Yeah, that's exactly it.
So let me try. I wonder. Let me see. Control Shift P. Since I'm doing something in Python. Uh-oh. Okay. Continue. Will it get mad at me if I make
Let's
another
see.
one?
I'll probably just overwrite it.
Let's just do this.
Yeah.
Overwrite.
Yeah.
See? This is nice. I
Ooh.
figured that would be nice because the reason why is because there's a lot of Python things that I use.
Yes.
And so if I do this, it'll give me all the Python stuff that I want. Like this is
Yeah.
all everything I use.
Yeah. That's a great call.
Okay. So there's the Docker file. Looks like it changed this.
Yep.
Here's a question. Because I know I have some dependencies that I need to install.
Yep.
And then I also know that I want to base it off of this image.
Got it.
So let me see. Let me try something. So let's see how good my Docker-ish isms is. So Control A, delete from this.
Yep. That looks right.
Okay, and then I'm probably going to need this conda dependencies file.
Yep.
So let me move that over here, and let me just change this to something smaller. So conda, conda, yellow, and I'm going to take this stuff out because this is Azure ML stuff, and I don't need it.
Got it.
I don't think. So there's that. Okay, so now I'm guessing it's just here. What do these args do?
So the args, this is what it's passing into the Docker file. So if you go to the Docker file, you can see that we're passing in the args. We deleted it, but they would come in as like environment variables. Yeah, you can see variant there and node version. So we can basically delete those with impunity at this point if we're changing.
Yeah, because we're doing our own thing. So I see. So there's the variant, and then okay.
Yeah,
that makes sense. So what I'll do is I'll go back here, Control A, Control Z, Control A, and then I'll say from this. Oh, I need to go back and copy it. So from this environment, this is the container I want.
Yep.
And again, I'm trusting you on because this is a GPU based container.
You can trust me.
I'm trusting you. We're going to do this. So because of this, I'm not going to need these args anymore, right?
Yeah, yeah.
So I'll take that out. I'm going to need to copy the conda.yaml over to, I don't know, just the current directory.
Yep.
And then run. Now, this is the part. Okay, this is the part I always get confused about. Okay, install conda, install packages from conda file. Google this with Bing. Here we go. Look at that. We'll just use that.
Easy.
Stack Overflow coding. Huh? There we go. There we go. Blessed day. And then we'll do the base environment since it's in that way it'll just run.
Yep.
And then we're going to use conda.
YAML.
Oh, oops. Now, is it with an A or without an A?
Without an A. At least your file is.
I know, but what is the right way? Should we be putting A's in there?
I don't know. That's a question for the broader community.
Oh, dang. So people are telling me on LinkedIn the screen is blurry. I'm so sorry. We're also on YouTube. I don't know why it's blurry there. I'll have to go check the settings. But we're on YouTube, and if you go to twitch.tv/Seth Juarez, you'll see it too. Sorry about that. I'll check that next time. Okay. So anything else I need to do? Like, is there any magic sauce of things that need to happen?
There's one more magic piece.
Okay.
When you're creating a container, you pass in an argument to say that I want to pass my GPU to this container. I want to access it. So in this case, we would basically make a new line in the dev container.json file.
So like right here?
Right here. Just make a new line. And then we're going to add if you hit the quotes and then type in run args, it should autocorrect. Or double quotes, sorry. And then type in run args, and I'll even tell you. There we go. And so now we're passing in basically like strings that we want as run arguments to our container. It's the exact same as if you typed in Docker run these arguments.
Got it. That makes sense.
So, and then we type in -- GPUs equal all.
GPUs all.
Equal all. And then there's an equal instead of a space. Yeah, exactly. Okay. That's it. And then now because we're going to be running this in Linux, right, from WSL, because that's where the Docker instances are, then it's going to pass in your Linux GPUs, right, which equals your Windows GPU.
I see. So is there anything else I need to do, or is that literally it?
That should literally be it. I think you're now all set up.
So this will basically set up the environment for me in a container, run with a GPU, have VS Code all set up, happy for me with all of these things. So now what?
So now what? Hit Shift Control P, and then it's open your command palette, and then do open in a container. So type like open, and then space remote. Remote.
Open remote.
Oh, what's the command? Let me look it up.
Is it this thing over here?
Oh yeah, we could click that as well. I usually open it straight from the command line.
See, that's because, again, genius. So there's this. Is there? What am I doing?
I got it. It's type in reopen in container. That's why.
Reopen.
And then space. Yeah, in container. So then there's an option rebuild and reopen in container. See it?
Yes, here?
2 more down.
1, 2. This.
Yeah. Remote containers, rebuild and reopen.
Okay. So I will do that. Control Shift P, reopen in containers. So we're going to do rebuild. Is it rebuild without cache or reopen?
I would do rebuild and reopen in container.
This one.
Yeah.
Okay.
Yep. That's the one that I use.
Things are happening. Here we go.
Shut down the instance. VS Code is opening it up. I would hit show log. It's really cool. Okay. And this is where all the magic that VS Code is doing is happening.
Is this opening in the container?
Yep. It's built your container. It's opening it, and it's doing a really cool Docker run call, connecting all the pipes to VS Code, and then it gives you an error.
Did I do something wrong?
Unable to find user VS Code. No matching entries and passwords.
I have an idea.
Yep.
I'm guessing, and you tell me what you think. By the way, we went back to I said open. There is no user VS Code, right?
Yeah, we can access that. And then we can use the root user instead. And that should be fine.
By the way, this is cool. It's actually showing me, oops, Control Z, I messed up over here. It's actually showing me what happened. Cool.
Yeah.
So go over here and just comment this out.
Yeah, I would just comment that out.
Okay, cool.
And then we can run as the root user.
All right, Control Shift P, and then I'll do this again.
Yep. So that's what's cool about it is like the container, let's say you had some other error, right? Some other Docker error or something was wrong. Anytime that happens, you can see exactly the error. You see the full logs from Docker, and it just makes it a lot faster. So you don't have to push to the cloud and then go, oh, oops.
And the reason why this is going a little faster, my friends, is because I actually tried this in a different project and I kind of made it work. And so now I'm glad you're here to explain stuff to us. And so it already cached the big image.
Yep.
Oh my gosh, what's going on here?
Maybe
I'm doing something wrong. Okay.
It looks like some Docker thing. But there you go. We're there.
So now I'm in the container.
Yep. And you know how you can tell really easily?
How?
Look at the bottom left of the screen. You see dev container Python 3.
That's how you know. Oh my goodness.
Yeah. And so if you click that, you can reopen locally. You can rebuild the container.
Where does this name come from?
I think that comes from the dev container file at the top.
I get. Okay.
Yeah.
Okay. So I can be this can be like the Rochambeau AI.
Yeah.
Container.
Yeah.
Okay. Well, let's try it again. Control Shift P.
Also, my other favorite thing about this, so I use the Vim extension in VS Code because I love the Vim, keyboard shortcuts.
Sure.
All of and you didn't notice this because it's so seamless, but all of your normal extensions propagated to the container. So your theme didn't change. It's not like you're running on a
Oh,
totally
that's
different machine.
right. Like that's the thing, and that's the thing that's kind of magical.
Yeah.
Is that I am sitting here opening it. I'm like, oh, this is just Visual Studio Code, but it's not. It's Visual Studio Code in a Linux container.
Yep. It's running entirely different, right? It's running entirely on a different machine. It's running even in a different operating system than where the UI is running for this, but all your extensions stay the same. For me, my Vim extension stays the same, so I program the exact same way, no matter what environment I'm on. It's really cool.
Oh, look, there's the name. Look at
there
that.
we go.
Some branding we got going on over her. Oh, man, dang it! I missed my calling here. I just have one button to push.
Sorry, I got it.
So cool. Oh, so whatever happened last time. Oh no, it still has something.
Something's going on, but that's fine. Doesn't seem fatal.
It's like the Jupiter. Is it? I think it's trying to, yes. I think it's trying to open like the Jupiter thing, and it's just I can't do that. We're not using Jupiter.
The Jupiter tooling's failing, but that's fine. It's not causing anything.
All right, moment of truth.
Crash. All right, well, we hit the same error.
Python. It's like we're trying to hit the same error.
Will it almost work?
Will it almost work? Config. Config. Okay, here we go. Things are happening. Life is good. We want the same error. Same error. Here we go. I feel like I need to put some like dramatic music. Here we go.
Oh, it's building. Oh, what else we should do is open the task manager, and you can see it hit your GPU.
Oh, hurry. Task manager. By the way, it's going to break, so
that's fine. We'll see if it assigns memory.
Oh, look at it. It sees it. It sees it. You're like, it says 0, Seth. No, we're counting in computer science.
It's happening.
Oh my gosh, you got the same error.
All right.
It's so perfect. Wait,
hold on. It almost works.
Hold on. Look at that.
There you go.
Oh my gosh, this is so exciting. Look, and you have no idea. And look, I'll be honest with you. A lot when you're using like container-based training, a lot of your time is spent, I got to rebuild a Docker container. I forgot this pip package. Doing this locally and making sure it's doing the right thing and then using the exact same Docker file is legit fantastic. Oh, so anything else I'm missing? Well, let me try. Let me see. Let me open this up. Here's another question.
Yep.
Like when I'm working on this, where is this file writing to?
Yeah, so it's doing a bind volume mount to your actual file. So if you go back to that .dev container, you can see how it's doing this. Okay. And then scroll down a little bit, and let's see. Or maybe it's up. I'll have to take a look at mine. But it basically it will mount your actual where your workspace is. It will mount it to the same as your what you're developing.
Is it this thing? Because I saw this. This is by the way, this is a Docker desktop, which I have a license to now. I purchased a license because their licensing is different now. This is legal. I am all legal. So basically VS Code mounts the volume. Is that right?
Yeah. So it's essentially it's the exact same files, right? In the exact same place is how you can think about it.
And this is what this is doing. Okay.
So the one up there, that container is running and it's accessing that volume. And it's basically, so all your files are in sync in step.
So Loving Allen is running. This is all happening inside of Loving Allen right now.
Yes. Yes.
I wonder what their name generator. I've always wondered how their name generator, because that is fantastic. Okay, so that was the other question. This is all basically running off the same file system. Now, the other thing, and here's a question that I wanted to ask you because this was super interesting to me. When I'm in File Explorer, there is this new this thing. What is that?
So it's our friend Tux, the Linux penguin. Do you know Tux?
I know who it is. I know it's Tux. But what is going on there? What is going on there?
So this is a WSL feature. When you enable WSL on your machine and you install distro, we put this inside of your File Explorer, and you can access your Linux files directly from File Explorer. So if you click on it, there's your distros. You can click on Ubuntu, and then you can fully go through your root file system totally in File Explorer. Where this is really cool is if you have, we have another feature called WSL-mount.
Okay.
That lets you mount other disks on your machine that are formatted in ext4 or like Linux file systems. So let's say I had a drive on my machine and I was dual booting, right? I was dual booting and I dual booted to another drive that had all my Linux stuff. You can actually mount that into Windows now through WSL and then go look at it through File Explorer.
What?
Yeah, it's really
like
cool.
A black hole when you're like, oh, I got to boot into Windows today instead of booting to Linux. It's not a black hole. You can totally mount it and take a look at your ext file stuff.
Yeah, exactly.
That is bananas. And this here, are these the containers? What is this?
Yeah, Docker Desktop creates two distros to house its container data, basically. So those are the two distros where all the containers live and all the runtimes for the containers live. As an end user, you don't really need to worry about them.
Because you told me I had to go click this, right?
Yeah, so that's the default now. If you install Docker Desktop, like nowadays, you'll get this by default. But if you're using an older version, perhaps you'll need to go to Settings and then click Use a WSL2 based engine. And then now everything is running in WSL2 in the backend.
And then the last question I have is, GPUs are so finicky. Is there something that needs to be installed for it to work properly, like the way we just did it?
Yeah, so there is basically, there are changes that need to be done to your GPU driver to make this work. And so what that is you basically need to go install a specific driver. If you're on Windows 11, this just comes by default. So on the latest versions where this is, it'll just be by default one of your drivers. However, if you're on the Insider program right now and you're using things and you don't see your GPU, I would basically just go install it. The easiest place to go find it is if you go to aka.ms/WSLG. That is our place where we have our GUI app repo. Yeah, that's it. And we have our link to the drivers there right at the top. So installing WSLG, there are the drivers. So the NVIDIA, and there's also Intel and AMD because we support DirectML as well. So you can do training on non-NVIDIA based GPUs as well.
Hold on.
Ah, yes.
You almost beat me on that one. Wow, that is pretty cool. So if you have a Windows device and you have an Intel GPU and an AMD GPU, because of the DirectML hardware layer, did you say DirectML?
DirectML, yep.
You're able to do all this stuff as if you had an NVIDIA GPU.
Yep.
Dang. All right. Is there any question that I should have asked that I didn't?
Let's see.
I mean, I feel like this was pretty cool. I mean, setting it up, I'm glad I recorded it so I can remember for the next one. Because having this is going to save me a lot of time. Because how many dev containers can I have in a single project? Just one?
I'm pretty sure you can make multiple kinds. I'd have to go look. I've only ever used just one.
Okay.
But also you can basically just copy this setup that you have and paste it. So let's say you make another machine learning project and you're like, oh, I want that exact same machine setup that I had for this one. Just paste it. Then you have the exact same Docker file. Everything works. It's exactly the same setup.
Will it cache this too?
Yeah, so it basically builds a new container each time. So the layers of the container that you're using will be cached. I don't know if like you're probably going to hit new layers because of what you're running on, but at least the base image and what it's building on top of will all be cached. Yep.
This will be cached, but not this.
I don't know for sure. Potentially, depending on how Docker slices it.
All I know is this happens super fast.
Yep.
I need to figure what this is. I don't know what I'm doing wrong.
It looks like one of the extensions that we're choosing is just not loading. We probably just have tons of extensions that aren't set up, like the Jupyter one. That's my guess.
Where's the Jupyter one? Let's take it off. I think I know.
I'm not sure.
It's the Jupyter thing is installed by default in the Python stuff.
Oh, okay.
But we'll figure. It's probably trying to get out of the container.
Yeah.
Cool. All right. Well, this has been amazing, my friend. This has been super enlightening. I'm glad that we've had a chance to look at these and how to do this. And this feels like a better workflow all around.
Yep.
Where can people go to find out more other than WSLG?
So if you want to find out more, the best place is to go to aka.ms/WSLDocs. That has everything and anything WSL, from getting started to best setup guides to how to use Docker, to all our tips and tricks. And if you want to follow the latest WSL news, you can follow me on Twitter. I'm at Craig A. Lowen, so CraigALoewen.
Well, hold on, we're gonna get Craig A. Lowen. Did I get that right?
I can't see, but probably.
Hold on, wait. Is this? Oh, you can't see because I'm not showing my screen. Here's the docs, by the way, that I brought up and no one saw.
Yeah,
this right here.
Oh, there's an E after the LO, so LOEWEN.
LOE.
Yeah, it's
Low.
German.
Yes.
It means lion.
Am I following you? Why am I not following you?
Oh, embarrassing, Seth.
Follow. Follow. That was sad. Look at this. Linux on Windows, totally. All right, my friend. This has been super amazing. Thank you so much for being with us, bud.
Thank you very much. Thanks for having me. And have fun coding everything and anything Linux on Windows.
I think I'm going to change my whole workflow, man.
Sweet. You should.
All right,
that's what I do.
All right. We'll see you soon, bud.
Thanks. See ya.
Take care. Bye. Well, that was fantastic. That was so cool. Yeah, I'm glad he came on because I feel like I've been doing everything like wrong. Craig A. Lowen. That was just cool. I mean, look, here's my beef with a lot of this stuff with AI is like, I love Windows. I've been using Windows since, I don't know, the early 50s. Since Windows came out, you know, I've been looking out of Windows since I was a baby. I've been looking out of Windows since I was a baby. That was a terrible joke, Seth. Terrible. I love Windows. But there's some things that I just need to do on Linux. Jay is saying that was quick. Takes me days to figure out. I know, me too. That's why, like, because there was an email thread. I kid you not, where people were like, "Why aren't you using WSL?" Well, it's slow and I don't know how to do it. And they're like, "I don't think you know what you're talking about anymore, Seth." And I'm like, "Really?" They're like, "Yes." And I'm like, "Well, I love being proved wrong, especially if it makes me happy." With Windows sucks. Blood Covenant. Windows sucks. Lol. I mean, maybe. But I mean, this here is bananas. Look at that. Linux. Look at this. Linux. Also, by the way, I'm running like 5,000 different things, so if it doesn't run fast, I'm sorry. There it is. Linux. Linux. Oh, I can't look at those things. Permissions. And I gotta run this as a. This is Linux. Oh, great. Now how am I gonna get out of this? That was Vim, by the way. I made a Vim joke. This is officially a computer science. Yeah. Oh, here's a good. Linux rules except when you want to game. Yeah, I agree when it comes to like building stuff, but if I can have Linux, and Windows at the same time, it's like I never understood this phrase, Blood Covenant. Maybe you can help me out. Having your cake and eating it too. Like if you have cake, aren't you eating it too? Yeah, you're right. I just don't like switching machines. But again, this is Linux. I mean, what's a command in Linux? Kernel. Get the kernel version Linux. Okay, let's ask it. Check the kernel version in Linux. Let's see here. The kernel is the blah. Uname minus SRM. It's Linux. Linux. Let's see what else we got. Host name CTL. Oh, I can't. Fail again. There's a way to oh, let's try this one. Cat proc version. Look at that. Linux. But yeah, I agree. I like Linux for that. Oh, I know. Did anyone else spot the Microsoft? Here, just FYI. Yeah, we build Linux too now. We build Linux too because you know what? We don't care what you run in the cloud. The slower, the better. But yeah, Blood Coming, you're right. I mean, this is a good. Linux does rule with certain things, like particularly in Python. Like if you want to do Ruby dev, Linux is better. But why not have both? Great. All right, maybe we should get our stuff to work now. Here we go. Here we are in a container, and I broke something. Line 44. Line 44 on trainer. Where did I break it? AI model line 44. Oh, of course. It's like what do you call? What is this, Seth? Of course this is gonna work. Gosh. Now let's run it again. See what we got going on here. Here we go. By the way, looks like everything's looking good. Incidentally, oh, something else is wrong. Cannot unpack non-iterable none type. What did I mess up on? Trainer 966, trainer 986, safety, utilities, CLI. Trainer line 23. Trainer line 23. Oh, we got that. That's the trainer line 23. Save patch. Accelerator. Trainer line 1244 and hook. Oh, that was a mistake we made last time, remember? I know what this is. So if we go to model, we cannot log the model type. Remember? Self.log, where is it? There. Because it's a string. Remember? We can't do that. Because it didn't like it and it broke. So let's go back over here and let's run it again. And now we should have things going. Here we go. Sanity check complete. Oh, now it's running. By the way, this is absolutely bananas. I think everyone, including myself, forgot. I am in a container running Visual Studio Code defined by the very environment we'll use inside of Azure ML. This is banana. We're running inside this thing. Look at. Oh my goodness, this is so cool. This is cool. Huge fan. I have been wrong about this my whole life. Wrong my whole life. I'm glad Craig Lowen could help us out. Thank you, Craig. Thank you. My life has been changed. Look at this. This is not running any slower than it was on my machine. But remember, it's running in a container that's inside of WSL, which is Linux, that's hitting my GPU. Again, I feel like I needed to I think we need to sit here and just bask in the glory of this goodness. I know. Bananas. I think I should change to accuracy instead of loss because, yeah, this is. I mean, I don't know what I was doing. Like, I've always wanted to do this, and for some reason, I kept I'm embarrassed to say I kept saying, "Hey, when are containers going to work on native Windows?" They don't need to. They already work on Windows through WSL. So thank you. This is still going at it, and it seems to be working. Looks like the ML runs are in here. Gosh, this is just crazy. I'm gonna go over here to the file. Let's go to the file directory. C Projectos Rochambeau AI. Let's look at the outputs here. Let's look at the logs. Let's look at the last one. Yeah, literally right now. Right now. This is crazy. In a container. Saving model. Let's open that again. Let's see if it saves the right model. C projects. Rochambeau. AI. Outputs. Model. Bananas. Look at it. It's right there. Oh yeah. Remember? Because I tried to save something. So it broke. Look at that. It's right here. It's literally just right now. This is bananas. I don't know if I'll ever do this in a different way again. I mean, it's crazy. Okay, so looks like I need to fix this thing. What do we got going on? Trainer line 23. Save life 74. This. None type object has no attribute. Results. None type. I wonder. Let's do something. Let's do a max, I think epochs, 1. I think that's the right thing. Let's check it. Python trainer. Hold on. Let's ask. Let's Google with Bing. PyTorch lightning CLI. Here we go. Lightning CLI and config files. There's a way to write them out. There it is. Print config. Not there. Here. Yeah. Print config. Default config dot. Yeah. So, good reminder. We want to add more properties, attributes to the model metadata. There it is. Let's make sure. Max epochs. That was right. So max epochs is going to be 1. Yes, I am doing. That's what I'm doing, Jay. But what I want to do is I want to set max epochs to 1 so that we can iterate faster. Because it's saving. I want to speed it up and make sure I'm logging to the right place. Because it was doing the wrong thing. Logs, model type, size, and file. Okay, so let's go and figure out how to log ML flow log attributos. Let's see how to do with ML flow. ML flow log param. ML flow log param. But I think there's an active run. So how do we get the active run so that we can log it to the right active run? So let's see. PyTorch Lightning ML flow auto log. Okay. Self.log. Cool. Okay. Okay, maybe I'm putting this in the wrong spot. I think I'm putting it all in the wrong spot. I don't know. What do y'all think? Let me move this down here. Go away. It feels like I don't need this here. I think I need it here. Right? And then it looks like yeah, look at that. Train the model. It says trainer.fit. But since I'm using the CLI, maybe if I do this. Thoughts on this? Okay, let's run this and see what happens. It's only going to do one epoch this time, so that's good. So clear, because CLS only works on Windows. What? And let's run it. Beep 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 beep. No, not that. Already did that. Beep 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 beep. Ugh. Oh, I did it again. No. Okay, here we go. That one. It's going to do one epoch, so it should be fast. This is still bananas to me. Like, it's like I live in a new house. Like, it's like I have a tiny house that I'm living in right now. That's a container to run this goodness. Oh, I should Control Plus. I want to make sure everyone can see this. Control Plus. Beautiful. This is fantastic. Beautiful. Excusez-moi. Okay, so this should all finish and run. It should all finish properly. Oh, yeah, I forgot to take that part out. This. We were going to do a breakpoint. I wonder if it still works. Let's debug. Yeah, it's still there. Still there. Open launch.json. What's the problem? What we got going on here? Couldn't find a debug adapter descriptor for debug type Python extension. Might have failed to activate. Maybe that's what's going on. I don't know why that doesn't like this. None type has no attribute results. OS path.get size. Print. F string file size. Let's take this out. Yeah, looks like we're dumping the JSON file out here, which is good. By the way, where's everybody coming from? Tell me where you're from. What's going on? What AI questions do you have that I can answer when we sit here and wait for things to run? I might not know the answer, but I'm sure very good at Googling with Bing. I'm the best. What param size is not defined? Did we not param size? From downtown Seattle. Coming to you from downtown Seattle, Jay McCormick. What the heck? You should be in there. Param size. ¿Qué pasó? ¿Qué pasó? I think the reality was that this parameter size in the wrong place. And the reason why was because the parameter size we want to get from the model, they're the same. They're actually the same now that I think about it. But let's do this. And the model is self to Onyx. Model dir. Let's see if it likes this. I don't know why that would change anything, but here we go. Man, this is still too cool for me. I'm not going to get over this in a while. It's cool. I can make an inference project with its own set of, like a slim container. This is just too cool. All right. One epoch. Guan. Why doesn't it like that? I think it's the log that has a problem. I think it's the log that has a problem. I don't think log exists here. Try that one more time. I think I'm gonna have to figure out why it's not running in the container debug. I think it's something that I did myself, so I'm gonna go back to trying to figure out what's going on here. Yeah, because we want to get a good model size so that we can run it in the browser. Here we go. Here we go. Yeah, so file size worked. Let's take a look at the outputs here. Model, Resident 18, params, model size. That's all there. So that's good. I think the reality was, I think the reality is this logging is just not working here. Because logging is done. Okay, let's take a look at how logging works again. For brevity, it's just simple, most minimal example. Blah, 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 blah. Output, yes, yes. Parameters. That's the thing I want to do. I want to log parameters. Where's the parameter logging happening? Get default pip, load model. Oh, this is cool though. You can actually load and save models using PyTorch, MLflow, PyTorch log. Maybe this is it. Because it's within the context of that run. Maybe if I do, let's try it. Let me try it. Let me try it. Import MLflow. And then if we say over here, here we go. MLflow log. Why isn't it giving me autocomplete? Let me save this. Let me go back to, how do I go back? Control-Shift-P. Let me close that, open it again. I think I have to fix something in here. Something in here is not right. Maybe if I just take these all out. Yeah, something's not quite right. Maybe it's a language server. I'll have to ask about that. Let's go over here. We were in model. And then we're going to say mlflow.pytorch.log. What does this one do? Log state dictionary. Huh. Okay, maybe that's it. Let's take a look at what the documentation says. mlflow.pytorch log model. Okay. Load state dictionary. Okay. This may change and be removed. Log model. Okay. Okay. Extra files, extra pips. Wow, we might have to figure out how to do an MLflow model because then I don't have to do any coding. Right? Just use the MLflow model. Save model. Here we go. Extra files. This message may change or remove. Dang it. Oh, it's a local file that needs to be removed. Or to be moved or done. Okay. I wonder, let me go to PyTorch Lightning. MLflow, let's just do that. PyTorch Lightning, MLflow documentation, MLflow logger. Self.logger.experiment. Whatever MLflow supports. Okay. Okay. Let's see if that's true, kind sir. So this is going to be, I wonder if you could do a type hint. Python type hint. Oh, Python type hints. Why they're important and how to use them. Oh, colon. What's the type that comes out? MLflow logger. I think it's this. Let's say logger of this type equals this. And then I can say, let's see, control dot. Oh, code. Code. All right. Okay. I think that's what's going on. Logger dot. Oh. I'm just going to take this goodness. I'm thinking const because I've been writing in JavaScript a little bit too. Hyperparams equal this classes list of string Yeah, we need to leave that in there. I wonder if this will work for hyperparameters. Let's try it. It says string of any. What's the worst that can happen? This, we can just say hadith. Okay. Let's see if this works. It might not work. You know what? Let's play it. See what happens. Here we go. I know. I went full Dr. Evil, Ivana. So sorry. Dr. Evil. Evil. All right. It's going to work. By the way, I got a new patch for my backpack whenever I might use it. You like that? There we go. Look at that glorious patch. Go single. Go single here. Glorious patch. That's right. The strongest steel is forged in the fire of a dumpster. That was for y'all to look at. Okay. It's going to do one epoch. Things are going. Let's do a little break-a-point. Let's go to debug console. None. Where is the logger? Is the logger gone? I think. Yeah, I think the loggers are gone at this point, which is weird to me. I think I need to tap into because it's a method that I built and it's getting accessed, and this is my guess, but we'll figure it out. And it's getting accessed after the fit has happened. Maybe the logger is gone at that point. Is there any notion on loggers with the trainers? Oh, we did this one. We did this already. mlflow.org. I'm just thinking, like, docs, blog, get started. Examples, maybe. Examples, no. Bolts, no, that's new. API reference. That's what we're looking at. I mean, that's what we're looking at. Loggers API, base. We could build our own logger, which would be cool, but I don't think I want to do that. Why do we need to do that? There's already good stuff. Lightning supports the most popular logging frameworks. Blah, blah, blah. Blah, blah, blah. There you go. Look at that. It's ginormous. Logging is all loggers by default use OS get current work directory to blah, 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 blah. Log image. Comment ML is their party logger. Blah, blah. Configure trainer. Comment loggers available anywhere except init in your Lightning module. Okay. MLflow. MLflow is the bright loggers. MLflow loggers. Blah, blah, blah. So transfers like this. MLflow docs. Yeah, it looks like it's everywhere except here. Something is not right. because we don't see that with ML Flow. You know, like it says it's in any of these things. Test logger, weights and biases, wand B is how I look at it. Multiple loggers, so trainer. The loggers are available as a list anywhere except in it in your Lightning module. South loggers is 0. Add image. Yeah, but like it was clearly gone at this point, right? Oh, I know why. Oh my gosh, I know why. I know why. The reason why it's gone is because we're loading a model from a checkpoint and it's no longer in its training mode. It's not training anymore. So it's completely gone. That's why it's not working. Oh. Do you see what's happening? So the reason why we don't have access to a logger is because when I load this model from a checkpoint, as far as it's concerned, this model is a static thing. We need to do this as part of the training process. So let's look at the Lightning module. And let's see what the things that we can override are. Well, let's go to the docs. I'm not going to look at that. That's what's going on. That makes perfect sense. Makes perfect sense. Tutorials, references. We want the Lightning module. Lightning module. Here we go. Backward, configure callbacks, so configure optimizers. Wow, this got really big. It's too big. He's too big. I wonder if there's like an after fit on the model when it's done training, where we can do all of this as part of the training process. Like we save the best model, and we log all the stuff. I think that will work. Okay, get progress. Training step end, training epoch end, validation step, validation end. I'm just trying to figure out if there is a like what are the things to. Let's go to the tutorials. I think it's in there. From PyTorch to Python. PyTorch Lightning. Yes. Yes. Forward, training step, validation step, configure optimizers, prepare data, setup. No, this is something else. Testing, bonus tip. Yes. Congratulations. I know everything now. Yay. So basically what I'm doing now is I'm trying to find a PyTorch Lightning method that I can override that has access to the logger to log out the things that we just logged out. Lightning module, we got that. Schedulers, validation, test, remove any CUDA to device. Lightning module. Yes, 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 yes. Yes. Maybe in the no, I want to do it as part of the training process. Here it is. When training using an accelerator that splits data from the sometimes you need to aggregate them on the master DPU step. Now this is when the training step ends. Validation loop. Validating with parallel. Test loop. Inference. Predict step. Oh, that's interesting. I should do that. Oh. Shared step. Yeah, that's what I had too. I wonder, like, because I have a shared step too that I wrote. But I wonder where there's the API. Configure optimizers. There's got to be, let's see, methods. So this is on every epoch end, but there's got to be a. Maybe it's here because it just doesn't exist here. I think I moved it. We don't need this anymore. Test epoch to Onyx to torch script, training step end, training step epoch end, unfreeze, validation step, validation, right prediction, right prediction, dictionary, freeze, log dictionary, manual backwards. Interesting. Oh wow, it has this print method. That's interesting. Predict step. Oh, we should definitely implement this too. Save hyperparameters. There's got to be like a when it's I am done thing. Let's see in the hooks. Huh. Let's go to the trainer. Maybe the log is in there too. Trainer. Huh. Okay. Okay. We're gonna figure this out. I wonder. I don't know if I want to do it this way. I feel like I'm doing it wrong. Param size, file size. I feel like I'm doing this wrong. This feels dirty. I'm not gonna lie. This feels dirty. Okay. Logging in the trainer. I've done logging in the trainer before. Let me pull up a project I did before. GitHub.com. Seth Juarez. Tlaloc, the Aztec god of rain. Let's go over here, trainer. Thank goodness for code I wrote a long time ago. Am I right or am I right? Right. Oh, yeah. So self.trainer.logger is what we want. There it is. We did this, though, and it broke, right? This broke, if I remember right. We did this, and it didn't work. Namespace. Model. Is it a namespace? Like, should I be go to definition? Subparams. Arc parse namespace. What? Object for storing blah blah blah. Log hyperparameters. Let's see what we got here. Maybe Lightning will tell us. Oops. Searching. Search. Did I just break everything? I broke everything. Let's search. Search. Logging hyperparameters. Okay. When training a model, it's usually no hyperparameters in the model. When Lightning creates a checkpoint, it stores a key hyperparameters with the hyperparameters. Some loggers also allow that and using test tube logger on the board, hparams tab. Self.hparams. Self.hparams. Let's see what those look like. Self.hparams here. Boom. Okay. Oh, we're still on a. Let's see what's in there. Oh, it's definitely not going to be in here. Because. All right. Yeah, it's not going to happen. Maybe it will. Self.hparams. Yeah. I wonder if I can add stuff to the hparams dictionary and then log it. They're like, use Elasticsearch. Maybe. Perhaps. At least I know kind of what's going on. We've just got to find a way to log. But basically, what I was trying to find was, like, when training is over, there's got to be a method that PyTorch Lightning calls that says training is over. This is in the CLI. I'm trying to do it in the model. So when the training's over, it saves it automatically. But I'm not finding it, right? And that's the problem that I'm having a hard time with. Like, where is the where is it? There's a property. Propiedad, property, log. Because the logger's dead at that point. There's no logger. Because I'm loading it statically from a file. Log dictionary. Write prediction dictionary. Forward, we got to override. Training step, that's the one we got. Training step end, got that too. Training epoch end. Validation step. Yes. Validation step and yes. Validation epoch and yeah, we got that. Test step, we don't have that. Test step and test epoch end. Predict step. Configure callbacks. Configure optimizers. Oh wow, that's a manual backward. We don't want a manual backward. Backward. Toggle optimizers. Untoggle optimizer. Optimizer step. Optimizer zeograd. T2 split batch. Yeah, this is now the stuff we don't want to override. Yeah, we don't want to override this part. To Onyx. Yeah, see this does a good job. To Onyx, to Torch script. We should look at this one day. Maybe that'll make our model tiny. Model size. Oh, I didn't know we had that. Yeah, I don't know how you can't. You literally have to dump the thing out. The model size in megabytes. It always includes everything in the. Maybe we just do it here. Log the model size in the before fit. On fit end. Oh, maybe it's here. Maybe on fit end we just save the biggest one. Let's do that. That way we don't have to explicitly call save. We just do it as part of the. Let's stop this. What's super got in there? Nothing. If DDP is calling every process, that makes sense. So what we'll do is we'll pass in a model dir. Model dir. Oh, str. Sorry. Model dir. In the config, model dir will be. I think it's output model. Yep. Model dir. There you go. Outputs model. Cool. So then we can just pass that in. Model dir outputs model. Self.model dir would be in there. I don't know why we had to do this. Self.model dir equals model dir. Good. So then we don't need to pass this in. The class is list of string. This would be length then. I wonder what an array looks like in YAML. Let's try something. Let's stop this here because we're actually still debugging, believe it or not. Oh, no, maybe we stopped. Terminal. We stopped. I think it's right config. Let me clear this out. And no, we want this debug console we don't want. Let's go over here. and let's write out the config. Here we go. We're going to get this to work. We got a couple minutes. Once we figure this out and we're logging correctly, then we're gonna go gangbusters here. Okay. So Python trainer write config default config.yml. Give it a second. What we're doing is trying to figure out how to pass in the classes. But we don't want to do that, right? Because that comes from the folder structure. Oh, so many complicated things. What is going on? Print config. Oh, you goober. Print. Print config. Yeah, I don't like the control being in that thing. It's gonna be all at the bottom. I don't like this being controlled here, to be completely transparent with you. I don't like this. No me gusta. No me gusta. I don't know why this is here. What does this do? Oh, psh. It will do that automatically. Maybe. Yeah, it just feels like I need to do it in the trainer. Feels like I need to do it in the trainer. So let's do this. Let's go over here. Let's F5 this and see what we got. Like maybe there's something we can use in there to log the parameters. We're going to get this. By the way, anyone have anything fun planned? Oh gosh, it did this again. Anything fun planned for the weekend? I'm looking for advice on things to do. Any fun things? Here we go. Here we go. Oh, I pushed the wrong thing. That was dumb. I pushed the wrong thing. I meant to push this one. This will run the current file, which is nice, but not what I want. And what we're doing is we're trying to see what logging facilities currently exist inside of the trainer by setting the breakpoint to this. Oh my goodness, working? Take a break. Well, I mean, that's super privileged of me to say. Okay, what's going on? Oh, derf. I gotta take out all that other stuff that I put in the config, like the model dir. We don't need that. Okay, here we go. Now we're ready. Here we go. I don't even know if we need to do this anymore. I don't care. Okay, things are happening. Here we go. Here we go. It's only on twice. Then we're gonna get to the trainer here, and we're gonna just see what's in the. We're gonna see what's in the trainer. And oh, jeez. The heck? Oh, that's why I had to say parameters. Pardonnez-moi. That was my fault. stuff. Now I know why we have to do that. We learn something every day, though, friends, right? By the way, what do you all think of my my Visual Studio Code theme setup, etc.? Should I change anything? Is dark theme just not cool? Sorry, Shahjahan. I don't know what's going on. I need to go into the settings. I don't know why LinkedIn is not putting it out at the right thing. It's putting it out elsewhere. If you go to for example, twitch.tv/Seth Juarez, you'll find it there, or YouTube, aka.ms AI show live. All right, let's see what we got. Self.logger. Yeah, it's not in there. After fit, let's see, we got locals, self, class variables, data module, model class, trainer class. I think it's self.trainer. Self.trainer dot logger. Okay, there's definitely something in there. Why is there no self.trainer dot what we got in here trainer all underscore methods that we should not be touching. Okay, here we go. Accelerator. Fit, we got that. What's in there? Oh, interesting. So it's got a tensor board thing in there, which is great. I thought Autolog was supposed to grab this stuff. Go to definition. Autologging is performed when you call the fit method of the trainer. Autologging is only supported for PyTorch line modules. Particular autologging support for this one. No. I wonder if let's try this. So self.trainer.logger.experiment.log. Let's see what's in there. Methods, function variables, add audio. Oh, nice. Add custom scalars. Oh, interesting. I think this is all because I'm not making my... All right, so that's it. That's it. We're going to do it. We're going to go full hog. We are going to add our own ML flow logger. Where's the tracking URI come from? Autolog, you got that. Tracking URI. Where does that come from? Interesting. Oh, okay. 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 Just give it to the trainer. Okay. So I wonder... Is it in here? I wonder if I can pass in. I wonder if I can pass in the this in here, loggers. Let's see what the default thing says. Logger equals true. That's the only one. He's the only one. Precision, weight summary. 46. 14 minutes. Yeah, because it looks like the only thing that's in there is the tensor board writer. I wonder if I'm looking at the trainer. Maybe let's try this. Let's try this. Def, save, best. And let's just do this. What is this? Oh. Oh, unexpected indentation. And then what we'll do is we'll pass in the active run. I feel like this is cheating, but you know what? I don't care. I am just oh. Active. Here we go. Here we go. This, I think, will do it. Run dot log. Oh, jeez. Oh, there's no logging methods in here. What the heck? No. No. Why? Why? Go to definition, start run. Go to definition, start run. My watch is telling me to stand up. No, I'm not going to stand up until we figure this out. We're going to figure it out. Active run. That's it? I think if I just call this. Wait a minute. Honestly, I think because I'm using this start run, I should be able to just do this. I think we should be able to do this. Let's try this. Okay. Let's try this. We're going to try this. We got 8 minutes. We can do this. Let's try it locally and then run in the cloud. Not like that, though. I know. Here we go. No. There. All right, let's run it one epoch, and then let's see if it does what we want it to do. Yeesh. I think our problem was this. We didn't start a run, and remember it was creating brand new experiments all over the place. Mm-hmm. What? 78. Oh yeah. I can't do this. I gotta take this out. All of this gotta go. Y'all gotta go. This was not. Oh. What is this? Yes. This is all gotta go. Got to go. Remember that was null because of our issue. Okay, let's try one more time. Yeah, none type is because there's no active logger. You know? Here we go. Once we try this, then we're going to run in the cloud and see what we got going on. And we're just going to do one epoch, and then we're going to delete all the other ones and start. Run up the score. Oh, I had that print size. We don't need that. Take that out. But it worked. Looks like it logged the right thing. I wonder. Let me clear this. Let me clear this. Run one more time and see if it logs it all into the same experiment. Here we go. Yeah, we go. We're going to do it. It's going to work. It's going to be great. One ML run. And in params, we should see. Param size. Here it is. Yep, param size. Model size. Model type. Model size. Okay, cool. All the same experiment. Good. All right, so let's try running it in the cloud. Let's kill. Job. Yeah, everything stays the same. Let's just run it. Oh, set default. Here we go. Uh-oh. It's time for our walk-off music to get started here. Let's refresh. Run 21. That happened. I don't know when this happened. Let's delete all of these. Yes. Let's go over here. Yep. Stuff is happening. Here's run 22. Go, 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 go. It's only going to do one epoch so that we can get these things out. Pulling. We can get this in 3 minutes, right? 65. Prep. Sidecar. Context. Entered. You know, I just realized that I did not explain how any of this stuff works here. I should do that. Maybe next time. Here we go. Here we go. Here we go. Refresh. Come on. Come on. You can do this. Look at the time here. I still got 2 minutes. Dos minutos. Dos minutos. Come on. Go. 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 90 seconds. Running, minute 34, 32. Nothing in there yet. Refresh. These ones all failed. Remember, we're on number 22 now. Number 22. Here we go. Refresh. I feel like I'm like taking a test and I'm running out of time. 60 seconds. If they cut us off, it's okay. If you're on YouTube or anyone else, you'll still see it. I want to make sure that we see it. Dang it! By the way, next time, super excited to let you know that we are going to be joined by Tim Walls to show off some exciting new computer vision tooling. Also, more rock paper, scissors. FYI, that's what we're doing. It's been a pleasure and a privilege to be with you. Watch me fumble through this because, here we go. Here we go. Reality is this stuff is hard, and I want to show you that it's hard for me too. Here we go. There it is. Oh my goodness, there it is. There it is. There it is. We did it. You're all the best. We will see you next time. Thanks so much for watching. And if you ever need anything, please make sure to reach out to me because I'm here to help. Thanks so much for watching, and we'll see you next time. Take care, my friends.